Hello everyone. We'll be covering ratios in this session. Ratios will be covered in two videos. One I'll be doing today, and the next one I'll be uploading very soon. Ratio is one of the easiest chapter, but very important from the point of view from the CUET point of view. There were a few questions which came in the exam previous year too. I'll explain you the concept using some questions. You'll find the questions easy, that's for sure. For example, this one, if the ratio of boys to girls in the class is 3 is to 4 and the total number of students is 70, what's the number of boys and the number of girls? Well, I'm given the ratio. So 3 is to 4 is the ratio of boys to girls. So can I assume that the number of boys is 3 times something, say 3x, and the number of girls is 4 times something, say 4x. Addition of these two is given as 70. So from here I'll get 7x is equal to 70, and from here I'll get the value of x as 10. If x is 10, the number of boys is 3 times 10, so 30, and the number of girls is 4 times 10, that's 40. This is one of the ways, assuming the number to be 3x or 4x, 3y or 4y. Second way of dealing with this same question is you just better compare the ratios part with the actual value. I'm given the ratio of 3 is to 4 of boys and girls, and the total number of students is 70. Total is actually 70, whereas the ratio represents the total as 3 plus 4, 7. That means something which is represented as 7 in the ratio is actually 70. I repeat, something that is actually represented as 7 in the ratio is 70 in absolute value. So I think what should I multiply 7 with to get 70? That's 10. So that's my multiplier. By multiplier, I mean the number which when multiplied by the ratio gives you the actual figure, absolute value, the original value. If 3 is to 4 is the ratio, and if the multiplier is 10, the number of boys will come out to be 3 times 10, that's 30, and the number of girls will come as 4 times 10, that's 40. This method will be quicker and much easier. Okay. Now, the third way of doing the same is using the fraction method. You can find the fraction of the boys and the fraction of girls. That can also be done. But here, okay, let's talk about the fraction. What is fraction all about? Suppose the boys fraction. Boys are 3 over 3 plus 4 of the total. 3/7 of the total number of students. And the number of girls is 4 over 3 plus 4, that's 4 over 7 of the total number of students. So in case I need to find the number of boys, what will I do? 3/7 of the total number of students, that's 70. So it will come 30. And if I want to find the number of girls, I'll do 4 over 7 of 70, that's 40. So however you do, I'll tell you the method of solving these type of questions will be faster using the second method. That's the method basically about comparing the part of the ratio with the absolute or the actual value and then finding out the multiplier. Now moving to the next question, same round question. If the boys to girls ratio is 2 is to 3, and here I'm not given the number of students in total, but I'm given the number of girls only. The number of girls is 60. Now please note that something that is represented as 3 in the ratio is actually 60. So that means what should I multiply 3 with to get 60? I'm looking for the multiplier. I believe that's 20. 3 when multiplied by 20 will give you 60. So 20 is your multiplier. So we can get the number of boys quickly. 2 times 20, that's 40, and also the total number of students will be 40 plus 60, that's 100. I hope this is clear. You have ways to do these questions. You can use the fraction method. In case you use the fraction method, how will you do it? With the fraction way, I know the number of girls. What will be the girls fraction here? Girls are 3 out of 2 plus 3, the total of the ratio of total number of students. The number of girls is 3 out of the fraction of girls is 3 out of 2 plus 3. The sum of the ratio of total number of students is 60. So from here, 3/5 of total is 60. So from you can get the value of total. That's 60 times 5 over 3. So that will also come out to be 20 times 5, so 100. And if you have the total number of students and the number of girls with you, you can calculate the number of boys as well. 100 minus 60. But still, I would say this method will take less time relatively. Now, moving ahead, I'll show you more examples. Here, I'm given the ratio of ABC as 2 is to 3 is to 5, and I'm given the value of C. As I said, the part of the ratio will be compared with its absolute value. C is actually 20, which is represented as 5 in the ratio. So what should I multiply 5 with to get 20? That's 4. 5 when multiplied by 4 can give us 20. So that's how I can get the value of A. 4 times 2, that's 8. And the value of B will also come 12. So A is 8 and B is 12. You can use it, you can solve this kind of question using the X method also. You can assume the values of A, B, and C as 2x, 3x, 5x, and you know C's actual value is 20. This is A, this is B, and this one is C. So C, which is 5x, is actually 20. So x is equal to 4. See, we are doing the same thing. It's just that using x, we are writing everything properly. And I don't think in an objective exam, you need to write each and every step. Better you apply some shortcuts. Moving to the next one, x is to y is to z ratio is given as 1 is to 1 is to 4. Now, the sum of x and z is 30. The sum of x and z, that means something that is represented as 5 in the ratio is actually 30. 1 plus 4, the value of the sum of x and z. 1 plus 4. So something as 5 is actually 30. Now, something shown as 5 is actually 30. So I think 5 is to be multiplied with what to get 30? That's 6. So I'll get the value of x as 1 times 6, the value of y as 1 times 6, and the value of z as 1 times 6. So I'll get x is equal to 6, y is equal to 6, and z is equal to 24. Okay, checking the next one. Now this is another type of question which we can expect in the exam. It says if the ratio of the number of boys and girls is 5 is to 4, which of the following cannot be the total number of students in the class? Okay, let's check this question. Suppose the number of boys is actually 5x and the number of girls is actually 4x. Since it's a ratio, we have to assume some multiplier with it. The sum of them is 9x, 9 times something. So the number of students, can it be 18? Yes, it can be 18. If you have x is equal to 2, the total number of students will come out to be 18. So this is something possible. I'm looking for which of the following cannot be the ratio, cannot be total number of students. This B is also possible. If I have x is equal to 1, I'll get this 9 as the total number of students. 54 is also possible if I have x is equal to 6. 21 won't be possible. You can't have 9x is equal to 21 and x will come something in decimal, and that's not possible for the number of boys and the number of girls to be. That's why C is not possible to be the total number of students when the ratio is given as 5 to 4. Next question is, if I'm given the number of total number of boys and girls as 60, which of the following cannot be the ratio of the number of boys and the girls? Let's see where I can get the multiplier as an integer value. That will be the possible ratio, otherwise it won't be. Here, the total is actually 60 and in A, it is 10. In the ratio part, it is 10. So I believe my multiplier is 6 here. 60 divided by 10. 6 is the multiplier. So that's possible. This ratio is possible. 1 is to 3. The sum of the ratio is 4. That means something that is represented as 4 in the ratio is actually 60. So I believe the multiplier is 15. That's again possible. 15 is the number of boys and 45 is the number of girls. So this is also possible. 1 is to 1 is also possible because the addition of the ratio is 2, which is actually 60. So multiplier becomes 30 here. So the number of boys and the number of girls is 30, 30. But yes, this is not possible. 6 plus 1 will not divide 60. You will get a multiplier as a fraction value or a decimal value. So that's not possible because you can't have the number of boys and the number of girls a fraction or decimal number. You could have taken this question using the x method also, though we are doing the same thing. Instead of writing x, I'm just doing it without x. If I need to do it with x, how will I do it? I'll assume in case of A, the number of boys as 3x and the number of girls as 7x. The addition is 60. So from here, I'll get the value of x as 60 divided by 10, so 6. I'll get the number of boys and the number of girls, integer values, so that's possible. For B, I'll assume the number of boys as x because it's 1 is to 3 and the number of girls as 3x. Addition is 60, so for x is equal to 60, x will come out to be 15. So number of boys will come out to be 15 itself and the number of girls will 15 times 3, that's 45. In case of D, it's 1 is to 1 ratio, so x plus x is equal to 60, so you'll get x is equal to 30. So 30 and 30 are the boys and the girls number. But here, in case of C, what will happen? If I assume the number of boys is 6x and the number of girls as x, the addition of these two, when taken equal to 60, 7x is equal to 60, you won't get x as an integer. And if x is not an integer, your number of boys and number of girls will also not come as integer value. It will come in fractions, it will come in decimal numbers. So that's not possible. I hope this is clear. So what we understood from here that you have some relation between the ratio with respect to the absolute value and the absolute value has some relation with the ratio. It's vice versa true. You need to have them connected. That means suppose I'm talking about the total number here. So my sum of the ratio needs to be a factor of the total number of actual number of students. Sum needs to be a factor of the total number of students. That's what we need to check. One question which came in the previous year CUET exam was this. I don't think we can say this question is entirely a ratios question. This question can be taken as an equation question as well. The question is about the sum of two numbers is 40 and the difference is 4. So can I assume the numbers to be x and y? X plus y is 40 and the difference is 4. So I believe these are two equations. We can just add them and eliminate the one of the variables. That's y can be eliminated easily here. This is adding the two. X comes out to be 22 and so y will come out to be substituting the value of x in any of the two equations. We'll get the value of y as 18. Okay, so when I'm looking for the ratio won't be 22 is to 18. Note, this is not a simplified form. Ratio is always the simplified form of numbers. 22 and 18 can be further simplified by 2. You can divide the whole ratio by 2. So answer will be 11 is to 9. Remember, you need to always simplify the ratio. You can't leave it with any common multiple. Otherwise, also, if I talk about this question as a ratios question, I can check the ratio. As I said, the sum needs to be a factor of the absolute value. The sum of the ratio needs to be a factor of the total absolute value. So if I check using the ratios method, I'm going by the options. 21 plus 19, the sum is 40. Yes, that's fine that the sum is 40 and the absolute value is also 40. So that means the numbers are actually 21 and 19. But if the numbers are 21 and 19, the difference won't be 4. The difference is just 2. So this is not possible. If I go to the option B, 22 plus 9 will give you 31 as the sum of the ratio, which is actually 14. Not possible. We can't have an integer multiplier, so this is not possible. 11 is to 9 is the sum of the ratio is 20, which is actually 40. That means my multiplier is 2. So my numbers are 11 multiplied by 2, 22, and 9 multiplied by 2, that's 18. So the difference of these two is actually 4. So this is the possible ratio. Let's take the last one also. The sum of the two ratio numbers is 29, but they are in absolute terms, they are 40. The value of the sum of the two numbers is 40. I can't have an integer multiplier, so that's not possible. So you have different ways to deal with the question. Ratios will have more to work on. I mean, you have the part in which you need to combine two ratios. You're given a ratio, you need to find a value. We'll be covering those things in the next session, ratio part 2. Till then, please understand the concept, because this concept of multiplier selection, multiplier calculation will be used not only in ratios chapter but in other chapters too. The ratios chapter sometimes is a part of many other questions coming from the different chapters. All right, we'll just stop here. Thank you.